Video on linear algebra. On this video, we'll learn how to identify if a system of equation reduced to reduced row echelon form is inconsistent, has no solution, is consistent, has unique solution, is consistent, and has infinite many solutions. I'll just show a couple examples while I do it. So for no solution case, we're just gonna build up a matrix. So for the no solution case, I'm just gonna make something up. So when you have this matrix, the pivot point is 1, you go down, the pivot point is 0, and you go here. So this is your pivot point, so there's nothing in the coefficient matrix, and there you have something in like the augmented matrix side. This means the system is inconsistent. Not like inconsistent, it doesn't work. We can do further more examples. Let's make a matrix again. Let's do a 3x4 matrix. So same here. So here you have a pivot point, here you have no pivot points. So you just go down. Here you have pivot, here you have a pivot point. So this row is good, this row is good, but this row you have zeros. And zeros in the coefficient matrix, and you have a number in the augmented matrix side. This means the system is inconsistent and has no solutions. One solution, or like one unique solution, is just like the reduced row echelon matrix with like pivot points in like every good part, like which has pivot points in like every needed spot. For example, let's look at this. So here you have a pivot point right here, you go down, you have a pivot point right here. This is the augmented side. So you have x1 plus 0x2 is equals to 2, 0x1 plus 1x2 is equals to 4. So x1 is equals to 2 and x2 is equals to 4. That means the system has a solution, it's consistent and only has one single solution. Let's do another example. Let's do 1, 0, 0, 0, 1, 0. Same with this one. This is the standard form of reduced row echelon. 0s here, 0s here, 0s here, and 0s here. Each row has a pivot point, and the augmented values are right here. It doesn't matter if you have a 0 here. So if you have a 0 here, x3 is going to be 0. So the system is consistent and has one solution, but this is how you know if the system's consistent and a single solution. How do you know if the system has infinite many solutions? For this, let's make a matrix again. Let's do a 2x3 matrix. So if you have this right here, you have a pivot point here, you have no pivot, you have nothing here, you have a 0, and you have nothing here on the augmented side. So the last, if the row containing the coefficient and the augmented side has all zeros, that means the system is consistent but has infinite many solutions. Let's do an example. So x1 plus 0x2 will be 1. So 0x1 plus 0x2 will be 0. That means x2 will be free. That means if you have all zeros here, that means the system is consistent and has infinite solutions. I will do a problem on it in the next video, because like when you have infinite solutions, you have to write it in a generalized form, which is quite fun, but it needs a video on its own. Let's do another example. 0, 1, 0. So on this problem, you can see we have x1. This row is consistent because we have a pivot point. This row is consistent, we have a pivot point, and this row is consistent. Even though we have no pivot points here, the augmented value is 0. That means the system is still consistent and has infinite solutions. Yep. So let's go over everything again. No solution, 0 is here. Augmented side, you have value. Infinite solution, one solution. You have pivot points everywhere. All good. And infinite many solutions. One row has all zeros, including the coefficient and the augmented side. That's about it.